Start. Yeah. Yeah. I will be. See my face. Remote presentation. We can start. Thank you. Welcome. This is the DNSOP working group. We have 2 hours this session. I'm Benno. Tim is sitting over there. Suzanne is over here. Scribe is... Who's the scribe, actually?
Java Scribe is Dan York, and Brian Haberman will be helping him out because I don't think Dan can be here for the whole meeting. And our minute taker is
Paul
Hoffman.
Yeah, thank you, Paul.
Thanks all.
Okay. Welcome, Lehman. Excellent. Thank you very much. The note well. Take notice of this. Note well is also applies to this working group, of course. Blue sheets, please fill them in. We have a full room. We want to have a large room and for the next time also to accommodate everyone. Thank you. Agenda. We have a full agenda. So please bear with me if we are a little bit strict on time management, depending on the discussion, of course. We have some current working group business, the A name. We have something like the chair's introduction. We will give a brief context about A name and a new draft by Eric Negan. Sorry, I've mispronounced your name. About HTTPS SVC. We will give a little bit context how they overlap but also differ. New working business. It's not all new, but it's not the DNSOP working business yet. Is work on the RDBD by Stephen and maybe Karsten. Okay, some will give a presentation. New work by Paul, Maura, Giovanni will give an update, etc. If time permits, Krzycki, very good, will give a presentation on DNS covered. Good. Let's get started. So we want to start with the A-name discussion here. A-name has seen a number of iterations. After Tony did some redrafting of the document, it simplified the A-name draft, and it made a distinction between the authoritative part and the recursive part. So much of the complexity are in the recursive part, and the more simple use cases are in the authoritative part. A-name, at least it started out to solve a problem like an alias or a CNAME in the Apex. But it also has other solutions. So it's a solution, it spans a solution space. With the recent HTTPS SVC proposal, it addresses partly the same problem. Provisioning web services or names for web services on different, maybe multiple CDNs. So that seems to be an overlap. So the chair still believes they address different problem spaces with an overlap, but are still both worthwhile to explore. So let's keep that in mind when we discuss the different drafts. More specifically, A-name, and if you have more interest in that use case, A-name is very interesting if you talk about APIs. So if you go for virtualization, you have all kinds of services on different places that move around. You want to, so it's not specific. It started, A-name work started out for the web services and the CDNs and provisioning, but it has a larger solution space also for APIs and not necessarily web services, web browsers. Tim, should I mention something else on this topic to give some context? So for the A-name, keep in mind there's the authoritative part, less complex, and the recursive part. For HTTPS, it's straightforward, quote unquote, solution, but it probably needs some additional processing for the records. But we expect, I'm not a web browser developer, this additional processing is probably done by the web browsers anyway. Or might be end up somewhere extra work in libc, I don't know. But that's also something to discuss during the drafts. I think I give sufficient context on both the drafts. We reserved quite some time, 20 plus 20 minutes, so it's about 40-ish minutes, including discussions, of course. I think we go to the remote presentation by Matthijs. Evan will be in the room, is in the room, and will act as a backup for discussions and explanations. I don't think it's necessary, but okay, thank you. Sorry, I can switch this up now.
Hello.
Hello, Matthijs.
You can hear me.
Hello, Matthijs. Yeah, we do hear you. I do see you. And I think, yeah, on the large screen, you're also visible. Please. I'll go to the slides, sorry.
Yeah, thanks.
I think that's my task. This one, yeah. So just. You see the slides? Yes.
Yes.
Okay. Please go ahead and say next.
Next slide.
Anytime.
So Benno already mentioned a little bit on the motivation. So this slide should be a little bit of repetition. This is the motivation we started out. We want to do the CNAME at the apex. Obviously, it should work for the CDNs, but it's not the only use case, although admittedly, it's probably the largest use case. DNS providers with CDN customers now have their own proprietary solutions, and so it's hard for them to switch providers or support multiple model. Next slide. A little bit of history. Basically, forget everything before the -02 version. That version, I think, is the fundamental basis of A-name. Everything before had some issues. It required resolver support, which made it hard to deploy. It had issues with zone transfers, and so the rewrite actually makes it much simpler in the sense that it makes A-name processing optional in every place, but possible in any place. What that means is that an authoritative can do the A-name processing, but then the resolver can also do the A-name processing, and that might be redundant if both do them, but it still works. From there, I sort of took the editing obligations on me, and I made it first an editorial version, which is the -03, and then a one that resolves some issues that were still existing in the -02 version. Next slide. So the -02 version, for those who haven't been following the A-name work, is the much cleaner version. It makes the resolver support optional and even the target lookup optional. That means that if nobody's doing A-name, it's not so useful. It would be similar to just publishing address records in your zone, but the expectation is that the DNS provider will implement the target lookup at the authoritative as their alternative to the proprietary solutions. There's no longer an exception for zone transfers. There's lots of flexibility to that, to your use case. Yeah, let's go to the next slide. So the -03 is mostly style, structure, some moving text from the main body to the appendix because it's more background information. And I want to do this version before going into the issues to make it clear cut. So that explains why we have a dashboard 3. Next slide. Dashboard 4 deals with a lot of issues that were mentioned on the list, put into the GitHub, and then resolved. These 3, I think, are the main ones. The first one is A-name precedence. There was a discussion whether the addresses that are next to the A-name, whether they should override the A-name or could be used as a default when the lookup fails, for example. We resolved it to being as a default. That means in the Dasho 2 version that was already the case, so little text changes were needed for the Dasho 4. The second one is the Ttl considerations. When doing a target lookup, now when you have resolved the target and you're going to replace the sibling address records, the Ttl will be the minimum of all the encountered TTLs. So if you're doing a lookup in your CNAME or your A-name, you will minimize the TTL and then eventually will target, and so you're going to replace the sibling address records, and the TTL will be the lowest you will encounter. This is because when you're doing this at the authoritative, you're actually playing as a resolver, and so you can do some caching, but then you have a cache at your authoritative, and then the client will ask for records, and they will cache it themselves as well. So there's some TTL stretching here, and taking the minimum TTL will mitigate against this a little bit. We also put some text in there for those stretching considerations, explain what exactly happened. And the third point is whether the sibling address records should be in the additional section. Now, let me rephrase again. Whether when you do an address query, so Q type is A or quad A, whether the A-name should be in the answer section or in the additional section. A-name is part of the answer, so it makes sense to put them in the A-name section, but Tony pointed out that with D-name, this caused a lot of issues. Still, on the DNSOP list, it looked like there was a slight consensus, slightly leaning towards putting the A-name in the answer section. So the Dasho 4 has a specification around that and puts A-name in the answer section. Next slide. This is a list of all the issues we resolved on the GitHub. So you can see there's a lot of work being done. Next slide. There are some open issues. One of them is the loop detection issue. And the loop detection issue is the point where you're doing a query, an address query, and you're following the target. So an address query which has an A-name on that same name may trigger another additional query to look up that target. That can hit another server that has an A-name, and that will point back to eventually the same server creating a loop. And it's very hard to detect that loop. Jan posted this to the list with some options to resolve it. One option is to put the logic that a Q-type A-name means that the authoritative server should not or must not chase the targets. So that actually avoids or allows for a target lookup without have to worry about a loop. And the other one is having an EDNS option. And that says, don't chase targets, I know A-name myself. My personal consideration with the last one is that eventually we'll hope that browsers will query for A-name or similar record, and how will they signal that support? And also in the current version of the draft, we say authoritative can do A-name processing, resolver can do A-name processing. So if a resolver signals support for A-name, an authoritative could still chase targets because it wants to give the most optimized response. So that's one issue. Next slide. Another open issue is what to do if you're doing A-name processing and the target lookup fails. So basically how to treat an error response. My feeling is that you could use the currently known sibling adder circuits as the best effort, or another option is to return surfail, because on your lookup something unexpected happened. So would you give back a slightly less optimized response, or would you prefer to signal that that lookup failed? Next slide. So there's actually a couple of more issues. There's no slide for that, but Petter provided a review on A-name, which has some small issues that I think also need to be covered. Together with that, I think we should cover those issues hopefully shortly after this meeting. My plan is to publish a -05, and hopefully that will be a version that can go to working group last call. And I think that's it.
Okay, thank you. Any comments from the room? Questions, remarks?
Ben Schwartz, Google. I'm one of the co-authors on the draft that will be presented next, which, as Benno mentioned, also bears on some of these issues. And so I don't want to give too much of a preview or mix the topics, but I'll just say that I've come to the conclusion that I think we do want both of these proposals. That I personally think that we should probably standardize both. But I do think that there's an opportunity to simplify A-name by essentially taking some of the use cases that generate complexity and sort of pushing them over to the HTTPS service draft. And so for that reason, I'd like to see if we can not go to last call until we've had a chance to absorb both of these options and see what the best way is to divide functionality between them.
Yeah, thank you.
Evan Hunt, ISC. I was the original A-name draft author, and I wanted to make a similar but also kind of different point. I also don't think we should go to last call, but it has always been my opinion from the beginning that the reason I was doing the A-name draft was that I did not expect browser uptake of any other solution. I'm getting the impression now that there is some momentum for browsers to take up HTTP SVC, and I believe that if they do so, I would personally recommend that we not proceed forward with A-name. I'd suggest that we shelve it until such time as we have a really clear use case that justifies the weight on the camel. That said, however, since I don't know yet whether the browsers are in fact going to pick up HTTP SVC, I think we need to carry on as if they won't until we find out that they will. But I think that working group last call might be premature at this point.
Tim Wasinski. I know I made some comments kind of cautious about HTTP SVC, but I've really come around on it. I like a lot of the ideas, especially about putting stuff in there, but I never saw A-name as trying to solve the web problem. I always saw it trying to solve the name at Apex problem. And I think part of my problem, this is why I didn't want to sit up there today, because I spend way more of my day now talking about containers and sidecars and service meshes and all these things. And I'm thinking about, like, I see where A-name, I get host by name, right? I remember mentioning that to Eric, and I was like, how do we, and Eric had some great answers for that, right? And I look at all these zones. So I'm an operator, right? And I work for a crazy company that does weird things. And so but I spent a lot of time looking at zone data. I see no zones anymore with A and quad A in them anymore. And they do crazy things where they're just service cuts, they're just doing zone cuts all over the place, and then doing, oh, we're going to do AWS security based on doing zone cuts, and then everybody's just doing alias records, at various apex points and stuff like that, and nobody has an A or quad A anywhere. And it's just like, okay, this is a totally different reality than I think anybody's ever thought of, right? And so it's like, I think I'm in a weird world, and I understand that, but I'm trying to figure, I think they both have value, like you say, and but it's like, I think A-name needs to be simpler. It's probably the best way to say it. And I can see A-name being like your worst case performance thing for web stuff, and then, hey, that makes you want to move to the HTTP service much faster kind of thing. So, yeah, that's my opinion. But yeah, and thank you, Matthias, for all this work. And so I think it's really good. I think I think we need another rev on that if people want it. And I don't know if the working group wants to do 1 or 2. So we'll leave it to the chairs.
Brian Dixon, GoDaddy. I agree with most of the previous folks that HTTP SVS definitely is SVC is the way to go for the web use case. I'm wondering for the API use cases whether it's feasible to go back to the larger, more generic SRV if it's feasible at all. But it's something to consider as well. But definitely, my vote would be for putting a bit of a break on A-name until we know about the other proposal. Okay, thank you.
Petr Špaček, CZNIC. I think that the last call is, well, premature. The sections 1 to 4 are okay-ish and could solve the interoperability problem between cloud providers, and that's okay. But the processing on the resolver side, sections 5 and 6, need more work. So we either postpone the last call and refine resolver processing, or split it to 2 drafts and, solve the interoperability for cloud providers, and then go and look at the optimizations, because resolver processing is just optimization, not a requirement.
Yeah, I think the chairs will discuss both options with the authors. Yeah,
thanks.
Just to clarify, I'm not suggesting to do the current version as a working group last call. The issues that Petr mentioned on the list and the loop detection issue and the remaining issues need to be resolved first in a -5.
Hi, it's Ttl. Tim, you managed to confuse me a little. You started off by saying you never saw A-name as solving the web problem, but as just solving the C-name at the Apex problem, which I understand all those words, but to me, the compelling use case that C-name at the Apex was the problem for was the web, and I wasn't aware that there were other compelling use cases. And records at the Apex make a big difference there?
So for the remote participants, the different use cases are service endpoints.
Yeah, so then great that there's another use case. I'm down with that. But I think that it probably should be mentioned in the draft, what these other use cases are. So.
Sorry about that. Tim Wasinski again. Yeah, it's not even like the browser stuff. It's all the backend servers that talk to all the backend services that talk to all the various things that are basically, and they're just setting up zones. They're setting something at the Apex because it's like, why not? I have an Apex, right? Why do I need to actually add anything else to it? It's like they're an engineer. They're working in some application space, and the world is kind of wonderful to them, right? And so, and
wait. So you're saying the world is kind of wonderful to engineers?
Yes. So that is sort of a different use case than, but if you're in this weird container world, which everybody seems to be running into at full speed, right? There are just these elastic services, fancy cloud things that people get, and you never get an answer. You never get an A record until the very end, basically, right?
So takeaway is put that in the draft.
Yeah. So.
Eric Nygren, Akamai. And I think on some of those, that particular use case of cloud services, I think one thing that before jumping straight into A-name as a solution there, might be to step back and work with some of those folks to figure out what the requirements are. Because I think when you look at the requirements in that space, especially with things like service meshes and similar becoming more common, that oftentimes those things are wanting to go from a name to a more complicated set of stuff. Like they're looking to go to a IP port pair. So it may actually be that maybe even SRV or HTTPS server, something else is actually more applicable than the name to solve that problem.
Okay. So concluding here,
Can I comment on that? I am not convinced yet that we should put all the use cases in here. I feel like people seeing a name and thinking, hey, this might fit my use case. Now additional requirements will come there. I think a name initially the motivation was to have something else than the proprietary alias CNAME Apex solutions, and those all are basically point to a different name at your Apex. That is what a name provides. Sure, if the working group now thinks we should come up with a solution that fits both CDN and the service endpoints and the Apex, then we should take a step back. But that was never the initial case of a name. So putting all those many use cases in the draft, I'm not convinced that it's a good idea. It's a lot of extra work that's just delaying actual implementation of a name.
Thank you. To make some progress, well, I'm just proposing this without any consultation. Maybe, so in August, Tim always tells that all the Europeans are on holiday, so nothing happens. But maybe in September, October-ish, early October, we can plan a virtual meeting on this topic to get the use case or the overlap and the differences and more clear, straightened out, so we have something more, the next step for the next IETF meeting in Singapore. Okay, thank you. We will send some follow-up emails to the mailing list to coordinate this. Okay, thank you, Matthijs.
Yep.
Okay,
thanks.
so, okay, thank you. Next, yeah, Eric. Yeah, indeed. Indeed. So here's the clicker. Yeah. Oh, sorry. No, I switched it off.
No degree of eating. Okay, that's better. No degree of eating the mic would have helped in that case. I'm going to talk about HTTP SVC, which is a little bit of a mouthful. The goal here was looking at a bunch of these different use cases that were coming up in a number of working groups in TLS, DNSOP, HTTPS, Quick, and trying to see if there's a holistic solution for them. Because one of the problems we're running into is that we're running into this chicken and the egg of various things wanted to have some information in the DNS to use to prime before making a connection to an HTTPS connection. But there was a concern on the browser side on this, like, oh, if we have to go do an extra DNS lookup for that particular use case, what is going to be the performance impact? What's going to be the impact on bad home recursive resolvers that don't know about extra record types? And also, as you start accumulating these different record lookups, are you going to be in a situation before where it's not just one lookup you have to make, but it's 10 different lookups, and then you have correlation issues between them. So HTTPS SVC tries to look at some of these holistically. The things which some of the use cases we've been trying to address have been the encrypted SNI keys discussion that's been going on in the TLS working group, in which we've had a number of design meetings around. There's the ability to negotiate a transport protocol, in particular for HTTP3, where with HTTP2, you can use ALPN to negotiate upwards, but with HTTP3, currently the only way to get to actually use Quick is to first go through TCP via H2 or H1, and then get a header back that causes you to negotiate up. So there's an extra round trip there that having information in DNS could help skip. There is a use case of indicating that an origin defaults to HTTPS. So for example, in the browser use case, if someone types a bare name like example.com into a web browser, does the web browser default in to HTTP or HTTPS. Today, it has to go to HTTP and securely and get a redirect back. And this prevents an opportunity to have a much more safe and secure default as more things are becoming HTTPS by default. And then a long-standing issue on the DNSOP side is hey, we created this SRV record. Why won't the browsers implement it? And which led to a number of the A-name discussions of, okay, we need to create A-name because browsers won't implement, haven't implemented SRV, and that chicken and egg there, and being able to address that. But then also, it's clear that as we've been accumulating these use cases, there's probably going to be the nth plus one in a year or 2 or 3 from now. In fact, I've been kind of terrified at the number of people who have come up with other use cases, not all of which are applicable, since the first version of the draft was published. So being able to be extensible without having to go and add new record types that browsers would have to look up. So the goal here would be to have a single new record that browsers could resolve in parallel with the A and quad A lookups. That would be extensible enough that we could use for the next, solve kind of the current cases, but also be extensible enough to cover the next few. But also to do this in a way that is usable for operators, usable for site owners, and has some ability to do some of the kind of performance optimization so that it doesn't have lots of different RTTs in the case where it has been set up sanely. There's obviously going to be some corner cases where things are going to have more performance overhead. But I think another goal here is to have something that's compelling enough to finally convince clients and browsers that it's going to go implement it. And any one of these use cases, like SRV, may not have been enough to get browsers to implement it. But if we can solve a few of these together, plus the next few, and move to more secure defaults, that may be enough to, and has gotten some interest from browsers of this may actually be enough to start moving the needle and to do something here. So structure-wise, when looking at this record, there's a number of properties of this that end up being similar to the concept of SRV. And I think the idea here is that within a given resource record, or RR, there's a number of these things you need to glue together and return back to clients as a single unit. And some of those may be references off to other things to go use. So in the SRV case, it was you had as the name something which was basically the name and the port in the scheme, and the target of or the data of the RR was a combination of things. It was that service. It was a domain name. It was a port, and priority information. HTTPS SRV basically starts off with that basic kind of port and host name that SRV has, but then makes it extensible. So tied to those two and tied to that RR, within that RR, you can start adding on additional information, such as what is the application protocol, such as H3 that's supported, if there are any ESNI keys that are needed to negotiate and the handshake, what are those? And part of the reason why it's critical to have those kind of bound together at the RR is because, like in the ESNI discussions within the TLS working group, you may have these different services being operated by different operators. You may have both transitions where CNAME has switched from, or things are switching from one hosting provider to another, or you have operational upgrades, or you may have multi-CDN use cases, and you're trying to mix and match things like ESNI keys and which application protocol is supported with which actual services and ports to connect to doesn't work so well. So there are two forms of the HTTPS SVC record. One of the, if you look at the structure of the record, for the default HTTPS port and scheme, doesn't use any label prefixes, and that operationally makes a bunch of things easier. But in this alias form, the very first element is a service record type 0. That means that it's alias form. There's a priority that isn't used in this record, in this form, so it's 0. And then you have the service domain name. So in this form, it's purely an alias target. This is one which is handled by clients. There's no special it's similar to SRV, where there's no special handling that's needed by authorities, no special handling needed in DNSSEC, no special handling needed in recursives. And then there's the alternative service form, which is basically, which you can think of as an extensible SRV. So it starts off with that service record type 1 saying that it's the alternative service form, followed by a priority, followed by the that service domain name target, similar to SRV, but then a bunch of extensible information. In this, we're proposing to use the things in the alt service format, which is a format that's defined in an RFC in the HTTP working group, and then at least one browser supports, and is also part of how clients negotiate up to QUIC in the HTTP3 protocol. And so in this case, the first one of these records would say that you can either use QUIC to UDP over UDP to svc3.example.net 8003 with this particular set of SNI keys, or you could do HTTP2 over TCP to a different SVC2 with a different port with these other ESNI keys. And I think one thing I'll highlight here is that while web browsers is a common use for HTTPS, HTTPS isn't just about web browsers. Like, from a CDN perspective, we're actually seeing that a huge fraction of traffic that we have is no longer just from browsers. It's also from API clients, service-to-service calls, and a bunch of this information around kind of port associations and bindings and protocols are just as applicable to some of those in the cloud use cases as they are to the web browser use case. How do HTTPS service and a name compare to each other? I think they're complementary. They solve different cases. There's not necessarily saying that one may need to replace the other. I think there may be cases where if we look and say that we can have the two of these together and that they both fill things, that maybe we can reduce a bunch of complexity out of a name. It may be that looking at what is a coverage set of problem spaces we're trying to solve might be that there's a bunch of use cases out of a name that could just be pulled out and reduce the amount of camelage that's happening there. I think one of the big differences, and Ben helped clarify this in the slides, was that HTTPS SVC doesn't require any changes to DNS servers. It's basically something that's just a record type that has no special handling. Whereas a name, on the other hand, doesn't require any special changes to clients. The clients, you have a name clients, basically just all the existing clients magically work. With HTTPS SVC, all the existing name servers just magically work. So that's probably the biggest distinction between those. And I think, but on the con side there, that means that HTTPS SVC is only respected by the compliant clients. So to add support into clients, which would ideally would be something that I'm expecting would happen at the client library perspective. And if we've been looking at the ecosystem of client libraries that are out there, there's a lot of cases on the HTTPS side where there's so much complexity involved in making an HTTPS connection already that a lot of mature operating systems are starting to provide higher level abstractions. So applications aren't going and doing get host by name. They're going and calling some OS or library API that is going and dealing with all the cert verification, DNS stuff, all that stuff for them. And so that's presumably where this would get shimmed in there. A downside here is this is HTTPS specific, but again, HTTPS is not just about web browsers. And I think a consideration for this, if this is successful, might be that maybe there is a pattern here that some of the things we could learn from HTTPS SVC might be applicable to other protocols, and having either more generic or other record type that kind of leverages off some of the structure of this might make sense to have as more generic. And I think that may be also a question for the working group of how much makes sense to over-genericize HTTPS SVC versus keep it focused on the HTTPS use case. So next steps, we're going to be talking about this also in the HTTP BIS on Thursday. Initially, I thought that was the best home for adoption. I think in talking with people here, I think there's a question on whether it makes sense to adopt this in DNSOP or HTTP BIS. I don't have a strong feeling either way. I think that's up to the working groups and the chairs on where they think would be the most constructive place and where there's the most interest in doing work on this. But I think no matter what, it's going to be critical to get input from both of those communities. And I think actually I've been very pleased on the amount of great feedback we've gotten from DNS so far, in particular, as we, some of the stuff we had in the wire format didn't make sense, and we've cleared that up and I got some feedback from some browser implementations. In fact, there is already a bind 9 private type draft implementation that Mark Andrews did, and in the hackathon as presented yesterday, someone did an implementation in Unbound. I was kind of surprised before I presented it that there are already 2 implementations, but feedback, comments, suggestions are most welcome here.
Thank you.
Yeah, I think on the administrative issue, we had already actually, the chairs had already discussed this briefly, and I think what we're going to do is get together with the HTTPS chairs and we'll figure out where it belongs, but we're going to need review in both groups.
Mm-hmm.
Warren Kamari, would you mind going back to the thing where you had the alt service DNS, HTTP one?
Yep.
So a quick question, and sorry if you've already answered this, but it looks like there are a number of things that you can stick in, right? There's like H2, H3, MA persist, ESNI keys. How big do these end up? Because I could see this getting really large, which is fun for DOS.
I think that's definitely a concern, and definitely I think that becomes a matter of how much gets shoved in here, and there'll want to be some guidance on what is appropriate to put in here and what's not appropriate to put in here. Like, for example, one of the things that's been highlighted is that not everything makes sense to especially when DNSSEC validation isn't being done by clients. There's some things that might seem attractive to put in here, but would have unfortunate security properties. So I think the things that you would want to put in here would need to have some constraints on and some consideration on what would make sense there. There is already the alt service already has a IANA registry for the alt service parameters, which is part of why we're using this to kind of leverage off of that. And this draft just proposes adding on the ESNI keys, but that could potentially be split off as a separate draft and might make sense to do that. I think one question that's come up on the browser side that fits into that is, to what degree would browsers do this over DNS over 53 versus just doing this over DO, where some of the size issues become somewhat less of a problem.
Hi, Oliver Amazon Cloudflare. I like this a lot. And I think this is a much better and cleaner solution than ANAME. But you have managed to walk into the biggest pitfall that DNS has ever had with dealing with record type. You have subtyping. And that has always bitten us back in the foot and makes things very difficult. So I would propose that you get rid of this first numeric field in there and just have a case 0 with an empty string. Just type 2 or type 1 as it is in there. That would be my suggestion on this record.
I'm not sure I fully follow, but I'm happy to kind of follow up.
Basically, whenever you have some interfaces that provision interfaces, etc., they will write it based on the spec when it gets published. So when you do implement the next asked form or service record type, it's not going to get supported ever by most of the provisioners because it's a one-time only write process for them.
Mm-hmm.
We have this problem with DNS keys. We have this with all kinds of other records. So just have one format and that is extendable in the string at the end.
Mm-hmm.
Would be my suggestion. As for implementation, this is going to be easy to handle, but there is a question about the SNI keys in the multi-cloud instance. Given that a number of operators roll these keys over very rapidly, it's going to require online generation of these records.
That'll be, I think some of that may be interesting. That's probably a good discussion to have on the kind of the TLS side to see how that relates there.
Okay. So we have sufficient time, but I want to close the line.
Okay. Evan Hunt. First of all, HTTPS SVC is way too much of a mouthful. I'm going to call it hat tip service from now on. I invite you all to join me. You mentioned implementation status on the DNS side. Do you have any information about implementation status on the browser side?
Not yet.
Any movement at all yet? Okay. I mention it because changes in implementation status on the browser side will inform the decisions that we make with respect to whether a name is worthwhile, I think. And I'd like to figure out how we can find out what the early indicators will be if this is actually getting uptake. The other question I wanted to ask, Oliver already mentioned subtyping, and I don't fear subtyping as much. Did you give any thought to genericizing this so that it wouldn't be specific to HTTPS, and that maybe an additional subtype field that would indicate that if this is for a different but similar use case that's not HTTPS?
It's worth considering. I think my big worry about that would be that the RR set gets really big. Is that if you basically start putting all the potential services, if you basically put the like HTTPS as a key in there, and you don't do this and you don't do a prefix label, then your RR set has to contain all the different possible services that you might support. I think it's worth considering, or maybe worth having genericizing, and like there's a bunch of different things I've thought about on the genericizing front. In fact, a few years back I had a more generic draft that was very, very similar to this. But I think so one option might be to have the format be generic, but then for at least for a few of the most common RR types, or for a few of the most common application types, would just be to use a different RR type for each of those, but still bounding that fairly small.
Okay, thanks.
Sorry, I did close the mic line. So the last person. Thank you.
Lorenzo Colidi. I also find sort of I see HTTPS service SVC, and I just keep hearing the word browser. Why? There are lots of applications that aren't browser. I mean, you yourself mentioned API endpoints and container communication. I would like to echo the call to sort of, can we at least like try to design this to be generic and not like, because if we just keep using the word browser, we're going to end up doing some engineering that only actually really works for browsers. And so if you have something like a split like DNS resolver with and application model, like, most of Android is like that. You've got a DNS resolver and you've got a bunch of apps. You've got WhatsApp and this and that. And you could say that WhatsApp's a browser because it just uses HTTPS. But I think we might, TLS server. Yeah, TLS server seems like a good idea because it is, a lot of this is in fact TLS. But, SMTP also uses TLS. It would be really good if we didn't box ourselves in. And I think also that would actually argue for not doing this, maybe in HTTP BIS, so in the HTTP working group, but actually trying to do this maybe even here, So, well, actually, this group can't do protocols, or can it? I don't know. But it can. Yeah. Then I think, it would sort of, I think it would help a lot if we looked at, because I see maybe this can become what SRV never could, right? So, and I think for size, you're concerned with size, but like I think in practice, we're actually going to end up doing this over TCP and encrypted transport anyway, because you probably don't want that stuff in the clear where anyone can mess with, oh yeah, like I'm actually going to move this to a different port, right? Because like, oh, here's your new SNI keys because I'm in the middle and I happen to be your resolver. You don't want that anyway. So I think the sort of size constraints are really not, material anymore. But that's just my personal opinion.
So either discussion on the microphone or.
All right, Stephen Farrell. So I agree with the comment Oliver made that people are rolling ESNI keys every hour at the minute. Now, there's only one real deployment, but nonetheless. Yeah, I mean, I guess my take is if browsers implement this, then I like it. Also, it's not clear to me. I mean, there's an ESNI RR type in the ESNI spec. Is your intent that clients would look up maybe both, or what?
I had added a slide on that, but only put it in the deck for the TLS working group.
All right, I'll ask you then. You do that.
But I think one thing on the structure of this, part of why there is the alias form is to be able to either CNAME or use the alias form for whoever is kind of operatingexample.com to be able to have the option of delegating and pointing this over to whoever is operating the service, so that whoever is operating those servers could be returning this record and the ESNI keys themselves, so that in collaboration they could be doing that quick rolling without having to go and find some way of getting the ESNI keys back into the first party domain.
Yeah, but generally, I mean, if browsers did implement it, I mean, I guess you could handle it. But having the ESNI public key in many different formats and different places in the DNS seems like a downside, but I don't know what to do about that.
Ben Schwartz. So, okay, on the ESNI question, my view is that we should pick one, and I would like to pick this one and not do the other one, so that hopefully that answers that question. On the online signing thing, Eric just answered this, but in case it wasn't clear, if you roll the ESNI keys once an hour, you have to sign them once an hour in this format. There's no need for repeated signing. And on the topic of being generic, could you go back to the 2 slides, I guess? Maybe only 1 slide. This one. So you can see on the lower example that there's something there, _8443._HTTPS. So as defined, this draft does admit essentially arbitrary new protocols to be defined to use this. And the data type that's in the service field domain value is essentially a completely unstructured dict of keys and values in a registry controlled by IANA. And the existing definition of the alt service field value says that it is extensible to non-HTTPS protocols subject to IANA control, basically. So you can, if you write a draft that defines what alt service means for any other protocol, for SSH or FTP, then this draft automatically covers you. The only thing is that you do then need to do the name prefixing, as in the second example here. So in that sense, this isn't as HTTPS specific as maybe the name implies, but certainly HTTPS is the clear focus of the draft.
Mm-hmm. And I'm totally open to kind of the bike shed of names that are less of a mouthful.
Hi, Eric Orth from Google, and I lead the Chrome DNS team. Everyone keeps asking what browsers and other clients are thinking about this, so I thought I'd come give my thinking at least. So we like the sound of this, and we are tracking it closely. The one important caveat is the current thinking is we would only be doing this query when we have DOE, mostly because a lot of stuff in it, has been mentioned, is not very helpful unless it's in a secure context, as well as also we're a little bit worried about sending out a third query for each request when we don't have a good signal that the upstream recursive resolver is a nice modern one that won't crash if we start sending extra queries to it. So this does mean that, well, yeah, there's been talk about size, that maybe that's not as much of an issue if we are only doing this over DOE. It also means that if we need some of this information, like the zone apex issue, when Chrome is not talking DOE, there is still room for other solutions for this, like a name.
Thank you, Eric. Well, I will join the HTTPS working group session and discuss with the chairs how to proceed. Great. And where we can adopt the document.
Thank you.
Okay, thank you. Next is Stephen. Will you present? Yeah. Yeah. Okay. Next up is Stephen Farrell.
Hi. So yeah, I think we presented this draft last time. We got some feedback. We implemented the feedback in the draft. We'd like more feedback. Kind of done, really, now. That's basically it. What do I point the clicker over there?
Oh, I don't know.
Yeah. So this is the summary. It allows you to kind of express a relationship between two names. One of the pieces of feedback we got last time was that people thought, yeah, maybe that's interesting, but I'd like to be able to express or disavow a relationship, so it's kind of a negative one. And so we added that in. As part of that, you're going to possibly have a long list of people that you don't want to be associated with. So we changed the thing to say you can either have a name or a URL, and if there's a URL, then there can be a list of names. So those are the kind of two main changes. There's the optional signature mechanism is still there. These are the kind of use cases that I think we covered last time. So unless somebody wants to jump up, I won't say anything about that really. And this is the changes, which I mostly said. We had originally, in the first version of this, we had a DKIM-like syntax, which is kind of a little bit what was like the values for the previous presentation. This time it's kind of binary. We scripted up the sample generation stuff, so it kind of looks like it could work if people wanted it to work. And basically, we're just still looking for more feedback. We're not asking for it to be adopted just yet. If we get more feedback, and if that's of the nature that maybe this is something that might get deployed, then we're happy to kind of, do the changes to the thing and bring it to the point where hopefully we could ask for adoption. And I think here would be the right place to ask for adoption, if anywhere. Previously, it's been on the debound list because one of the apps ADs thought that was a good place to start discussion. We can move it to the DNSOP list if you prefer it. I don't mind that. And that's all I had. Jeff.
Hi, Jeff Hodges. Yeah, this has been a can we've been kicking down the road for a long time. It's on the debound list because we did have a working group a while back that was specifically working on this problem, but nobody had the time to keep pushing it forward. We just kept kicking the can. It does need to get solved. Andrew Sullivan and I believe firmly that this really needs to be in the DNS, this sort of information. This draft is pretty congruent with where we were coming from. There is a problem statement draft out there. If you search for debound in file names, you can find it. There's also the Startup Policy Authority draft, which this is pretty congruent with. Though this draft does not yet cover all the intricacies at this point in time. It kind of glosses over various things. Happy to provide feedback down the road on it. I think this is good work. It really needs to find a home and it needs to get solved.
Great, thanks. I mean, just on your comment about intricacies, my hope, and I don't know if it's realistic or not, is to not get mired in all the intricacies in this draft and just do the mechanism bit. But
well, that's what I meant.
Yeah.
Is there's some mechanism things that aren't mentioned yet in terms of the default. At this point in time, the default is assumed of everything relying on the DNS for the most part, that policy applies to subdomains, and that's not explicitly mentioned.
Correct. Yes.
And you need to be able to say at some node in the tree that no, I do not belong to the policy domain above me.
Awesome. So yeah. Okay.
And also, the current draft has it's optional for one endpoint or one node in the tree to say I belong to this other one. You can unilaterally say that we disagree. We really think that you need to say at both nodes whether or not they belong to each other.
Sure. I've heard that comment from a few people and disagreed with all of them. And I'm happy to keep disagreeing. But if it ever got adopted as a working group thing, then we would do the working group.
And we need to work. Our perspective is we need to do this, and we need to work through it and make it happen.
Yep.
Thank you. I'm closing the line after Murray.
Stefan Bartmeyer. I really don't understand why we don't, if we want authenticity, why we don't simply use DNSSEC. Today, the draft creates a very complicated authentication mechanism, copy and paste from DNSSEC, which adds a lot of camel hostile complexity. So why not just cutting everything out and saying, if you need to authentify this relationship, use DNSSEC, which is a proper way to authentify things.
Sure, you could. Personally, and again, if that's what our working group wanted to do, fine. But I think I'm still willing to make the argument that there might be value in cases where one part of the relationship does have DNSSEC and the other does not. And that's what the signature mechanism does. It is a bit complicated, but it's also a vast subset of DNSSEC. So DNSSEC is obviously more complicated than what's in here, but it adds to it, yeah, sure.
It's not a small subset. It's almost all the complexity of DNSSEC.
Okay. How long is a camel?
I'm not going to answer that last question. John Bradley, Yubico. I'm going to largely agree with Jeff. We have WebAuthn, token binding, a bunch of different projects I'm working on. If we keep inventing point solutions to address this, the same issues are coming up over and over again. Eventually, we're not going to, things will start falling over because we won't be able to keep up with manually maintaining lists and patches, and it is impacting WebAuthn at the W3C and other things where I'm getting emails as we speak about why can't Pfizer in the US relate their European domain? This is unreasonable as far as they're concerned. This is something we have to progress. Yeah, I'm not emotionally attached to this particular spec, but we need to move this ahead. This may be a reasonable way of doing it. I'd be willing to work on it to make sure that some of these, we have a broad selection of use cases that are covered by whatever the final document is.
Great, thanks.
Paul Wouters. In the past, I used to be fairly against this. I'm now flipping to the other side. I'm more in favor of it, of doing this. I do see some problems that are not solved, and I'm not sure if you can solve them. For instance, the one I see very frequently now at my day job is people doing surveys internally and then using a Google form and a shortener, and so then it's a relationship between me and all of Google, and then it sort of doesn't really help me if everybody points to these super generic solution farms domains. So I'm not sure what the solution for that is, and if that can be thought of somehow in this to have a more specific URL, I guess, because like I want to maybe specify some forms with like a Google form URL instead of just a domain name.
Mm-hmm.
So that's one part. I also agree with the if you use DNSSEC as the trust model, has some advantages. One, all the people that keep confusing transport security with authenticity of data get another slap on the wrist of doing it properly. And the other part is if the PowerBind draft moves forward, then that is actually your signal of saying I am independent of my parent.
Okay.
And so you would solve that problem there.
Okay, cool.
Hi, this is Murray, honorary co-chair. I talked about this the last time when you brought it up, and the DMARC working group is also we're interested in something like this. And we currently solve the problem with the public suffix list, for better or worse. And we've now just working group last call a document that is sort of a patch to that model that attempts to bring in slightly more use cases that are covered by that, but not quite. And I'm worried that we're going to continue on this path of kind of like one more warts rather than a more general solution. So I'd love to collaborate with maybe, can this do something that replaces that entire suite of use cases and solves that problem for us once and for all? I mean, there's a lot of people with allergies to using the public suffix list the way we're doing it and so on. So I'm excited about this. I want to see it move ahead. And if you need a home for it that isn't here, we'll take it or something like that. Yeah, this is good stuff. And if it simplifies our lives, then we'll be happy to move towards it. We even said in the DMARC document, as soon as something better than the PSL comes out, jump to that. So if this is that, then we want it.
Okay, great.
Thank you.
Thanks. So I guess the only question for now is, do you want to move the discussion to the DNSOP list, or do
Yes,
you?
please.
Okay.
Yeah, I think that's a good conclusion here. And please send feedback to the mailing list. And I think the chairs will discuss with you after the summer, of course, the European holidays, in September, about call for adoption. I think from the room there's a lot of interest and people want to work on the document, but I also want to discuss it.
Yeah, sure. Great.
Yeah.
Thank you.
Right. And as a side mark for the PowerByte, it's correct. The draft. From what I understand, there was some interest in the draft, but not on the mailing list, not expressed on the mailing list. So if people have an interest in the draft, please also express their interest on the mailing list, because it's now being discussed on the corridor, on the hallway. Please correct me, Paul, if not correct. So if people have interest in PowerByte, please express their interest, etc., on the mailing list. That's important for us. Okay, thank you. Next, we have Paul. Oh, sorry. Punit, sorry. I thought you're such a familiar face, Paul. Sorry.
Yeah. Oops. Because I don't break my mic. Hi. So I'm here to talk about the DNS resolver information draft. I just noticed that the link there is for one of the instantiations of the data types, not the resolver information draft. So we'll fix it later. Next slide. Yeah. So the main thing is we are looking for working group adoption, and the reason this draft exists is that the primary use cases it's originated with was for DOE, but there was some feedback that this should be generalized so it could be used for other pieces of information, and so that resolvers can publish more information about themselves. And the DOE information will move to a separate draft. So this draft proposes using IJSON to represent the information. It's presented in an extensible form using name value pairs, and the client can query for specific names or a well-defined name called inventory, which gives you a list of all available information on that resolver. So there are two endpoints specified for querying this, one over DNS, which uses the ARPA IP address of the resolver itself. And the reason for doing that is it may allow for using DNSSEC for validating the answers. And the other one is using HTTPS. Originally, we considered using a special use domain name, but that was dropped in favor of the ARPA DNS name. So here's the thing. This one, we are mentioning that you can implement this over DNS or HTTPS. And the client could also decide to query this information over DNS or over HTTPS, which leads to an interesting interoperability question, which is if the server and the client implement only one of them and they are not the same, then they can't figure the information out. So that's something we are looking for feedback here. Okay. That's it. Questions, feedback?
Ben Schwartz. So I think I support adoption. I would like to solve this use case. I appreciate the work here. I have some personal differences of artistic differences with the engineering choices here. I really liked the special use domain name formulation that you originally had much better than the reverse IP address formulation, because I think a very large fraction of users are behind DNS forwarders, with the result that the true recursive resolver in play has an IP address that is not known to the client. So, for example, if ISPs wanted to use this service to offer improved transports to their customers, I think for residential ISPs that would largely not work, because most customer equipment, most stub resolvers are behind a DNS forwarder in their Wi-Fi router. Now, if the Wi-Fi router actually just passes the true IP, forwards the IP address of the ISP resolver, then it will work. But I'd like to cover that use case. I also think that the .well-known solution is not necessary. I think it might simplify things if we just pick the DNS solution.
Thank you. Yeah, it's very brief. Yeah.
So you can I reply to that, Palo Alto? We just in Trans had a discussion about BCP 190 and using well-known, and we got pretty much shot down as in you cannot get an exception to that. So not using .well-known will be a hard problem. You'll first have to convince the art area to that BCP 190 needs updating.
So I think if the working group adopts this, we're going to have all of these questions. We don't need to do them now. And yes, we need to, if we go with .well-known, we're going to have to like get pre-approvals and stuff. So yeah.
So one gentle request. If you like, you can express if it would be working group or it will be adopted by the working group or not. Or do you support it or not? Just to get some sense from the room and from the comments.
I don't like.
Okay, thank you.
I keep the strategic remarks for later when we will have content to put here. But first, from a technical point of view, getting information about the network you connect to seems to me very close from what are doing the captive portal working group and also the entire provisioning domains thing that is done, I believe, in the internet area. So isn't it simply a very special case of provisioning domains, and should we instead rely on the provisioning domains draft, which is, I think, near to completion?
So to answer that, one of the initial use cases could be done in DHC, as you were saying, although when that was asked earlier in the DOE working group, there was very little interest in that. People said, no, we don't care. But in addition, this allows you to get other information about a resolver. It's not just for finding out about DOE. So a resolver might want to tell you other things about itself, such as, I prefer that you connect to me over TCP, things like that. So that is really this can be used by resolvers saying to recursive resolvers saying to stub resolvers, please do this with me, I am able to do this. So it really isn't a provisioning thing as much, because remember, not all resolvers are provisioned through DHCP. People choose other ones in other ways.
Still, it seems to me a very similar problem. So maybe it will be a good idea to add in the draft why provisioning domains is not a solution.
Okay, that sounds good. And I hadn't even thought of looking at CapPort. I will.
I'm closing the line after Ben.
Jim Reed, I just think this is an interesting piece of work, attempts to solve a real problem, and I think the working group should adopt it as a document.
Wes Hardiker, ISI. Shortly before the IETF, I was actually going to write something very similar. So I guess I support this in concept. I was going to do it in a completely different way. So the way I was going to do it was actually to create a single name that would give you a list of other records you could go look up, such like we already have some that are resolver based, like, what DNS key do you support and things like that.
So one note on that Puneet skipped over is new name value pair. If this goes through with the current setup, new name value pairs can be defined just by expert review, and specification required, meaning just an internet draft. So it's very lightweight for adding in some of those.
Yes, with the caveat that I was about to get to. So thank you. Perfect. Architecturally, we're doing strange things with the text encoding values in DNS. We now have records that are encoding in a number of different encoding, mechanisms, like SPF, has semicolon separated kind of stuff. This is now doing iJSON, and every time we fracture that, we are limiting or the number of things that can read it, or mandating that everything that needs to be able to read everything go off and include the appropriate parser. And I don't know positively that we want to do that. With respect to, it would be easy to add stuff. You're also building on gigantic record sizes and things like that, which is why I was sort of thinking about an index-based approach, and doing it instead. So, again, I think I support the concept in general. I'm not sure I support the implementation. I think that the DNSOP working group ought to solve this problem case, and we should get to what's the right mechanism. So I support not necessarily the draft, but I support the the moving forward of it.
And we're totally open to, like, for example, if people don't like IJSON and they want to go back to, like you were saying, semicolons in between such, sure, that's fine.
Well, and JSON makes perfect sense for the HTTPS pool because you already know that mechanism probably has it.
But as you say, this would add another parser for some people. Maybe that's too much. Maybe we don't want to do it that way. We can do it in some other format. That's fine.
On the Ben Schwartz, on the topic of provisioning, provisioning makes sense when you're speaking about local information about the network. I view this personally as non-local. At least my use cases, as I mentioned before, are essentially non-local. And in fact, architecturally, what I would really like, although I don't know if it's possible, is a DNS trace route that tells me that.
Can we cut the mic line before you?
So as we consider adoption, I think we should also think about what design space is open. What are we actually considering?
Yeah. And this might add into that trace route thing if certain resolvers want to say that and want to say where they're doing upstream. No limitation on that, regardless of the format that we come up with. So great. So you folks will figure out about working group adoption calls?
Yes.
Great.
Yeah. No, indeed. So I think concluding, there's interest, but I think we need some additional discussion on the mailing list, and then maybe on the mailing list, or maybe with the next IETF meeting. Okay. We go for adoption.
Sounds good.
Okay.
Okay.
Thank you.
Yeah. Thanks.
Okay. Thanks. So next speaker up is Giovanna. Right. There we go. Yes.
Yeah, good morning, everybody. So today I'm here presenting this draft version 4. Well, it's strange.
I did something wrong. Let's give it another try.
All right.
Yeah.
It's not.
Here, this did it. Sorry.
Yeah, it's all right. So this is just draft history. It was first presented at the 104 in Prague. Just documented the video, the slides here. And today, the version 4, we incorporated a lot of changes based on the feedback we had on 04. All those changes are open as issues. We're open as issues on GitHub. We want to cover that. And today, I'll be covering the most important ones only. And before I even dive here to start to cover them, I would like to thank again everybody on 104 for the feedback. I think it was a little defensive. That's probably the way I'm used to academic conferences. But when I went home and watching the video, it was like, these guys are right. So thanks for the feedback. It was really nice. So changes for 104. We had a discussion on the title of the word recommendation. That's very strong for the IETF. So we replace every instance of recommendations to considerations. Lehman pointed that point on. He was concerned that we could reduce the setup's heterogeneity if everyone would follow that recommendation. And then also consideration is the word used in several other DNS RFCs. And a note to self here, it's like an IETF recommendation is different from a paper recommendation. In a paper recommendation, it's more or less like an IETF consideration. Other issue, draft talks mostly about Anycast, but not exclusively. I think Joe Ibley pointed that except for the Ttl considerations, our other ones are related to Anycast, and he is right. But the thing is, like, this is a text we put there. Our fix is basically pretty much saying, yeah, that could be the case, can work for other applications, but we have only done for DNS academic studies, so we cannot actually claim that it would work for the others, but might as well work. Ttl Consideration Controversy, like Peter Koch, he pointed how complex the issue was before. DNSOP, like 15 years ago, people tried to figure that out. It was a very complex problem. And he also said, like, TLs is mostly for zone maintainers, not ops, but there's some operators that are also zone maintainers, TLDs typically. There's child and parent TTL as well, so it's an important issue. And to fix that, we actually rewrote the entire section, and because we had a new study covering specifically these considerations of TTL, I presented last Sunday here on IAPG, and has just been accepted on the next forthcoming IMC conference. This is here in this URL, you have actually the submitted version. A revised version will follow up after that. So pretty much we wrote the whole thing, and now we kind of we don't say like, hey, you should use a TTL of 1 day or 1 hour. We just like measure, we care a lot of scenarios and situations, and you show what are the consequences and the implications of the choices. Because before people wouldn't, people would just copy and paste TTLs and leave it running that way. But now we can actually make an informed choice on how to choose that, and regards performance, with regards caching, we got a bunch of stuff. So I recommend you to have a look at that. Paper selection, issue 15. Paper selection could be more diverse. We had 3 different papers to the references of this draft, which were not co-authored by us. We also had this piece of text here to just say, hey, this document actually covers, is based on research papers, and we recommend folks to read the related work section of those papers because they have a specific, they address that specifically. So that's what we have done. I think George Marcuson, he pointed out like Atlas, it's typically biased towards Europe for one of our considerations. That was like a C3. And he's right, but I did include, and we haven't included that on version 03 of the draft, that actually consideration about any cast in this paper, the folks, the authors, what they did not do only analysis for all the ripe Atlas probes altogether. They actually break that down into countries and regions. So the consequences of that is it's this text that we put there. It's given that, well, Atlas has a little bit more bias towards Europe, but the analysis per country, per region does not change the conclusion that location of anycast instances dominates latency. And just to remind us, it's also peer review. And I think that's the most important issues we have changed. There's many more, but they're on GitHub, and I just covered the basic ones here. Yeah, thanks.
Thank you. Questions from the room? Comments? I have 1 or 2 questions. So, Peter Koch and Joe Emily did give feedback from what I remember also from in the room. The last person. Did they read the new version?
I cannot say that. I'm not positive about that. No, I'm not sure.
I would be quite interested in their solution. So there are 2 things. There was the wording of the document that has to be adopted. Liman also pointed out that, and that has been solved. The other thing is, of course, to the working group. It's interesting to see that research can be, finds its way to operational practices or recommendations, etc., considerations. There's a group of people here in the working group. They think it's very interesting and very good to have these documents in the working group. And but that's more the previous discussion about the wording. So for the draft future, it's also, of course, up to the group what they think is a useful document. Because, and please speak up here in the room or on the mailing list. Also, operators. You also discussed things with Anycast operators previously, I think.
Yeah. So some of those considerations have been deployed by us, like done an hour by Beirut, by others as well. We have to talk about that. Yeah.
And their feedback was positive.
Yeah.
All right, so in the room, how many folks have read? I had the impression a bunch of people have read this document. Oh. Okay. Just as a quick hum to get where we are as far as the future of this document, because there have been a couple of versions here. If you think it makes sense for the working group to consider this as a working group draft, please hum now. If you oppose it as a working group draft, please hum now. Okay, so I guess the only thing we can say from that is we're asking the room for more review and you to continue to take the feedback on.
Sure thing. Thank you very much.
Yeah, Matt Poundstead. I have sort of a comment on the adoption question. Since this is a review, essentially a review of academic papers, I don't really see what the working group is going to do to improve it. It's an analysis of research that's out there, and so I don't really see what the contribution of the working group would be to improving it.
Mhm.
It really feels like an independent submission to me.
Okay.
Thank you.
Thanks.
Okay. Next speaker. Could you line us up?
Good morning. I'm Kazunori Fujiwara from JPRS. I will talk about avoid fragmentation in DNS. PassMT discovery is vulnerable. Details are presented in my presentation at OAK 30 and this IPG meeting. And DNS is said to be the biggest user of IP fragmentation because EDN0 and DNSSEC is widely deployed. Research papers described effective cache poisoning attacks using IP fragmentation and PassMT discovery. Fragmentation considered poisonous 2013, IP fragmentation attack on DNS 2013, domain validation plus for MTM resilient PKI 2018. As a result, we cannot draft fragmented UDP packets and PassMT discovery. Then we can avoid large UDP responses. EDN0 has requested UDP payload size field. We can choose smaller value, smaller than PassMTU. And RC 6891 section 6.2.1 says that, note that PassMTU with or without fragmentation could be smaller than this. And truncation works well. When responses exceed specified EDN0 size, servers return truncated responses and client retry by TCP. And TCP is considered resilient against IP fragmentation attacks. RC 7766 states that all general purpose DNS implementations must support both UDP and TCP. Then I would like to propose new recommendations. Full service servers should set EDN0 requested UDP payload size to 1220, defined in DNSSEC RC4035 as minimum payload size. And authoritative servers and full service servers should set EDN0 responders maximum payload size to 1220, same value. And more, authoritative servers may send DNS responses with IP don't flag, IP version 6 don't flag options. And full service servers may drop fragmented UDP responses derived from DNS before IP reassembly. It is a countermeasure against DNS cache poisoning attacks using IP fragmentation. And last night, Paul Bixby advised me that the constant 1220 is not good. Calculate from PassMT or LinkMT value. It is one idea. And we need a special consideration in small MTU network. When DNS servers are located across the link with the MTU value less than 1280, choose EDN0 requesters and responders maximum payload size fit to the smallest link MTU value. Otherwise, the response may be dropped. And the smallest MTU value minus IP version 4, version 6 header size and UDP header size is possible EDN0 size. Or maybe another recommendation. DNS servers should be located at networks where MTU value to the major part of the internet is larger than or equal to 1280. And deployment. The proposed method supports incremental deployment. When a full service resolver implements the proposal, the full service resolver becomes to avoid IP fragmentation in DNS. And when an authoritative server implements the proposal, the authoritative server becomes to avoid IP fragmentation in DNS. As a proposal case, DNSSEC or TC with shared key requires both requesters and responders support, not incremental. And I have concern about dropping fragments not written in draft. Drop fragmented responses and DNS responses with IP don't flag, version 6 don't flag options may cause DNS communication error timeout. And to recover the situation, full service resolver needs to retry by TCP transport. It increases complexity of full service resolvers. And how do you consider, do you support this recommendation? Or do you like fragmentation? That's all.
Thank you. Comments, questions from the room?
Hello, Lars Lehmann from NetNode. I think you're right in what you say. The technical content in there is quite okay. So my comment is just along the lines of, again, as with the last draft, how to put this to the end users and the people who deploy this. Recommendations is a strong word. Considerations might be a better word. Please have a look at how that is presented, and I would like the working group to make a choice here how to present that. If it's adopted to the working group, be careful about how you present this to the people who read it. That's my only comment. But technically, yes, good.
Yes.
Thank you.
Thank you.
Thank you.
Hi, Puneet from Google Public DNS. So we are in favor of fixing the UDP fragmentation issue. So in principle, we support this. I think figuring out the MTU and some of the deployment considerations that can be figured out on the working group mailing list.
Eric Nagar-Nakamai, have you been in coordination with the TSV working groups working on a PL PMTUD draft for datagrams? It's trying to address some similar things. It may make sense to collaborate with them to figure out, are there some ways to make this complementary? Because there may also be some ways to not have to set the low MTU in all cases, but only in certain cases.
Thank you. Currently, no, but I need this.
Petr Špaček, CZNIC. I'm on the pragmaticless side, so yeah, I do support the document, and as software developers, we intend to drop the maximum into EDNS buffer size, so effectively implementing what you are recommending. So yes, go ahead, please.
Brian Dixon, GoDaddy, but previously I'd done a little bit of follow-on research to the original fragmentation poison draft. It's much, much worse than that draft, or that paper was. If anybody's really interested, I can go into more detail at some later point. I'm definitely in favor of that, definitely want to recommend that the developers of resolvers change the default on their EDNS buffer size to get it down to a reasonable level. Thanks.
Mark Andrews, ISC. You mentioned TSIG. I've also got a draft which I've submitted using a well-known TSIG key, which effectively allows the DNS level to detect any fragmentation reassembly. A successful at the IP level fragmentation reassembly attack and reject such a response. Looking at the Alexa top 1 million, looks like 3/4 of the servers there could deploy a well-known key today with just a configuration update. That's about the level of that's the level where that's the level of TSIG deployment in that set of servers. So I think there are ways around this without getting rid of fragmentation. I realize people sometimes don't feel like they need to solve the fragmentation problem, but you end up with other issues going to TCP too. Just want the working group to look at both together, please.
Thank you, Mark. From the mic line, I do hear a support of the document. I want to ask the working group to look at the draft, the proposal written by Mark. And I think please give some reply, some comments, feedback on the mailing list. And we will discuss it with the chairs and with the author about the call for adoption later on the mailing list. Yeah, thank you. Any other comments? Excellent. There we go. Next presenter John Woodward on the bulk RR.
I am morning. John Woodworth here to talk about the bulk RR again. We've made a few changes. I've gotten a lot of good feedback from the last time I presented. So those of you who are not familiar with it, it is basically a compact or condensed representation that can expand similar to a dollar generate at a meta level. And it can also be transferred between primaries and secondaries in a condensed form. So a single record could expand into millions of records. It offers standardizations around some of the implementations that are already being done. Certain vendors have similar features and technology. This would just offer a standard way to exchange those records between the multiple vendors. And I've also, in the field, I've seen record or zone files that have expanded well above 50, even above 150 megabytes, which don't really transfer well. If they do, there's a lot of timeouts, a lot of errors. Sometimes they'll have to be manually transferred, etc., or broken into smaller zone files. The new draft, what I've done is I've broken it into two drafts. We had an NPN, which helps with the some of the offline signing capabilities in a pattern-generated record way. We also have a couple IPv6 examples with the new formatting. Yes, and I've broken up the NPN into a second draft. Thank you. And we are still trying to get this adopted by the working group. So any questions, comments?
Jeff Houston, how do you sign it? How do you sign it?
You either would use the NPN, which would modify the signature and the validation mechanism. There's another record, or you would do online signing.
Other comments? Please go ahead, Warren.
So Warren Kumari, Google. I mean, I've got a bunch of v6 space. It sure would be nice to be able to provide reverse DNS for it. there's no other way I can see to do that, like realistically. So.
Right. Thank you.
Oliver, yes, I read this draft. I like it. I don't like the name of the record type, bulk. I think it should be a rename or something like that. And the draft could also use some more examples of the input and the outputs to the expressions you have. They're a little bit convoluted, and some of us are afraid of regular expressions.
Right. Thank you. Yeah, I'm open. I think all the authors are open to renaming it as well.
And online signing is not a problem, Joe.
Thank you.
Thank you.
Yeah, we would like to see a little bit more discussion also on the mailing list before we proceed.
Right.
But thank you for the presentation and the revisions and updates.
Right. Thank you.
Thank you very much. So, permitting time, we had a presentation by Witold. So, and we have time. We're doing well all the time. So thank you all. There we go.
Okay, so this should be a short one. Yeah. Hi, I'm Witold from ISC. The idea is DNS resource record for transferring covert information from primary to secondaries. And don't ask me about the covert. We've had this discussion about how to name it. So the idea is to transfer something that should not be queried for in band with the zone. The idea is for it to be generic so that we can expand it with another RR types without changing the behavior of the server. And the examples include node RR, which we have a draft for this. Evan is here as an author. DHCP timeout from Tim. For example, NSEC5 keys if NSEC5 is adopted, and even zone signing keys for inline signing on the secondary. Although that's just an example. So don't be scared, because that's most of the discussion on the list was about examples, and that's just an example. It's a generic for anything. I think the biggest issue was that was on the list and in other discussions was about encryption and the security of transfer, because we are putting something that should be hidden, and then we don't encrypt it. We don't mandate encryption. So, for example, for NSEC5, the encryption is not needed, because if you have the zone, then the NSEC5 key is not needed for it. It's not necessary for you. It has no value. But for zone signing key, it's required. So the question becomes, should we mandate a form of security or a specific form of security like XFR over TLS, which will be discussed, I believe, tomorrow on Deprive.
Tomorrow or Thursday?
I don't remember. Yeah, but on Deprive. Deprive has
Thursday.
So those are the questions for the draft, and the details. There is a range in our type numbers that's currently reserved. We want to cut a piece of it for this kind of records. The question also becomes: should there be a private range for this kind of records, cut from the reserved RR types? There is a mechanism that disallows transfer to secondaries if they don't understand the covert semantics. So if there is a secondary that does not understand covert records, it won't send the EDNS option stating that I understand covert records, and it won't receive the transfer at all, so that it won't serve it. Also, the server must not serve covert records without an explicit ACL allowing it. That's, for example, for a node, because a node is a record that an operator might want to ask for, but it requires an ACL. The other thing that's not in current version of the draft, because I thought about it on Sunday, is that we should for generic binary types, we should change the name so that the zone would not load if it has covert records on a server that does not understand covert. And there is a usage we published those two drafts simultaneously, there is a note RR definition, which is basically a comment in zone that can be transferred with the zone. Because 1034 has a zone comments, but XFR came a bit later and those comments are not transferred with the zone. And sometimes it might be useful for operators to, for example, mark that this IP was given to this person and it's, it's just a comment, but it stays on the secondary. So yeah, that's it, basically. And
comments, feedback. Is it useful? Do we think it's should work on this?
Petr Špaček, CZNIC. It smells like database and ACLs on top of it, and I have a bad feeling that eventually someone will come and ask, hey, I want to have only this group of users allowed to query for this type, and that group of users allowed to query that other type, and stuff like that. And then you will have to invent mechanism how to transfer the ACLs and so on and so on. So I think it's can of worms, and it don't belong to DNS. Please don't.
Hi, Stephen Barrett. I guess I'd also wonder how to think through the cases. If you're transferring a ZSK over TLS, that depends on PKI, that depends on DNS. Things might go wrong there somewhere, right?
Like I said, that's just an example. And now I didn't want to put examples in the draft. I put, and now, that's what's happening.
Terry Manderson, from a principled point of view, just because you can doesn't mean you should. So a lot of this is orchestration mechanisms and orchestration information. I wouldn't want to see that in DNS.
So, Warren Kamari, Google, but no hats. So the special range thing and taking like a bunch and setting them aside, that feels kind of icky to me. Like, I'm not speaking about the rest of it, just the, going to take a check.
Well, the idea was, if you want to put, if you want to have something that's covert, then with each draft, you would have to specify that this should not be queried for. So the idea is to have a range in which you can put specific resource records like node, like DHCP timeout, like anything else that, servers would understand that they should not allow queries for.
To me, it seems like you could have a type for covert and then stuff under that.
But that's subtyping,
yeah,
and that's not allowed.
Evan Hunt, a few people have made the comment that this sort of thing doesn't belong in the DNS, and I just wanted to say that this sort of thing already is in the DNS quite often. It's just not in the DNS in a way that is resistant to open normal queries from just everybody. I have heard a number of people who are operators request a way of putting something in the DNS that will automatically be replicated to secondaries that isn't easily queryable. And there's already data that is used in DNS that is not easily queryable. You can't look up an NSEC3 record. You receive it if you look up something that doesn't exist, but you can't specifically query for it. Policy zones are often have queries disallowed. That's just metadata for the operation of the server, but it can still be transferred over a channel from a primary to a secondary. What this is a mechanism of having in-band data in the DNS that resists ordinary queries. And I think it could be useful in a number of use cases. And some of those use cases have already been done in a less convenient and less secure way.
Petr Špaček, CZNIC. I think that Evan has a point. Basically, this is inventing zone transfer protocol, which is intentionally incompatible with the old one, using the EDNS option to prevent the old slaves from getting the data, right? So I think it's opportunity to invent much better transfer protocol, which allows like more flexibility and don't necessarily stuffs all the non-DNS data in zone file, right? I mean, this is the perfect opportunity to do the right thing and do new zone transfer protocol because the old one is quite horrible. So.
Wes Hardiker, ISI. We have traditionally, so two points, I guess. One, DNS is not designed to be a entity-to-entity type mechanism. So we have transferabilities and things like that, but we expect caching. We expect things to be transferred beyond that. We have signatures that exist over portions of it. We have a draft that is signing the whole thing. So you end up in these cases where if you have partial zones where some entities have part of the zone and some entities have all of the zone, you'll end up with...
No, in this case, all entities that have the zone have the zone.
If the covert records are not allowed to be transferred, then that's not going to be the case.
Then they won't have the zone.
So, right, they won't have the whole zone, which means they can't validate records that have...
No, they won't have the zone. If there is a covert record, a zone cannot be transferred to a secondary that does not support covert.
Right, so
period.
You're prohibiting transfers entirely. Okay. So, second point is that in a security context, we almost always insist on private information to be transferred out of band, not in the original protocol. So it's unclear to me why it is needed to be in band in DNS protocol as opposed to a supplemental bit of information like how we currently transfer security related information.
Okay.
Jim Reed, I'm sorry to say I think this is a very bad idea. Well, first of all, it smells a little of security by obscurity, and then we create some kind of special secret sauce where some special resource record types have got a special significant meaning, and that will then determine the behavior of the server and how it then responds to queries. I think that's a very bad idea and the start of a very, very slippery slope. If we're going to set aside RR types and say these are of special significance and they can be queried by certain clients or certain servers under certain circumstances, I think that's a very, very bad thing to do. I think it will create very many difficult interoperability and operational problems if this stuff escapes into the wild. Now, yes, there might be a need for some kind of these kind of what I would class not so much as covert information, but as out of band information. That might be a better description of it here. But if that information is sensitive, don't put it in the DNS. The DNS is public.
Largely on that note, Wes beat me to it. I agree that I think this type of information doesn't belong in the zone. I can see a need to transfer such information between two servers, but I think to do it in zone is probably not the best approach. I'm listening to the comments here. I think that having some kind of parallel transferring structure, maybe invent a new transfer type instead of normal zone transfer or incremental zone transfer. That transfers parallel information, or we already had the NS control protocol, which is another method of transferring data. But I don't feel really, it doesn't feel right to have it inside the zone.
Brian Haberman relaying a question from Jabber. Could this be done with catalog zones instead?
Well, catalog zones convey information about a zone as a whole. And in this case, we can, for example, for node record, we can have a record in the zone, because we can have a record in the zone. So for example, mac10.isc.org and the node stating that mac10.isc.org is Evan's computer, which catalog zones are a concept. Well, it would be possible to, for example, transfer zone signing keys with catalog zones, because those are values that are attached to a zone. But in this case, we want to have something that's in the same hierarchy as the zone. So if we can have a record in the zone and a node for this zone and a node for this specific record. So yeah, in this case, for example, for node RR or DHCP timeout RR, it's not possible to do it with catalog zones.
Paul Hoffman, just since I'm busily typing the minutes, I think that Peter said something that many people agreed with afterwards, but didn't say they agreed with, which is this is an opportunity to create a new zone transfer program. If people don't like doing it this way, which it seemed like a bunch of people didn't, but they agree that there is a use case and might even have extra use cases, which it seemed like a bunch of people did. A different zone transfer program, it could be parallel, that only does not zone. We aren't wedded to AXFR and IXFR forever if we can come up with a better way to do it. And I think I've seen better ways to do this written on whiteboards for the last 10 or 15 years. So maybe this is the opportunity to do that, at which point in that new transfer, it's not just zone transfer, it's zone information transfer, or zone configuration transfer as well, could include this.
Okay. Thank you.
Thank you.
And thank you for all your contributions and comments on the microphone. Any closing remarks? Well, please fill in the blue sheet. Thank you all, and see you back in Singapore. Thank you. And thanks for the note taker, Paul, and the scribe, Brian. So please fill in the blue sheets. Yeah. Excellent. Yeah. Yeah. I give you 5 minutes. Yeah. Yeah.